What's up, George? You're going to be learning about how to write linear equations in slope-intercept form today. And so let's kind of go through these notes. One of the ways the equation of a line can be represented is in what we call slope-intercept form. Okay, and we've learned about this equation. The equation is y equals mx plus b. If you ever see a linear equation written in this form, y equals mx plus b exactly in this form, that is slope-intercept form. So in the equation y equals mx plus b, m, let's review, is our slope, which is, rise over run in fraction form, and b represents the y-intercept, where our line crosses the y-axis, intercept. Okay, so in the end, our goal is to write an equation of a line or linear function using slope-intercept form. The goal is to identify the slope and the y-intercept to plug those values in for m and b to represent our y equals mx plus b formula. So our goal is to write an equation of lines, which is going to be in the y equals mx plus b form. And the format is always going to be in slope-intercept form for this. And given to work through this, we have to have at least 2 points on the line from a set of points, tables, or graphs. So you can do it with points, tables, or a graph. Step 1, graph 2 points contained on the line. Step 2, identify the slope of the line m from the graph using rise over run. Step 3, using the pattern of the slope to extend the graph up the line. Step 4, identify the y-intercept b from the graph, which is going to be the point where it crosses the y-intercept or the y-axis. And step 5, write the equation of the line. So let's kind of look at this first example here. Our first step that we need to do is use rise over run to determine the slope. And so remember the equation that I taught you, right? We have the y2 minus y1 over x2 minus x1. Okay, so I'm going to just choose 2 of these points and plug them into this equation, and my slope will come out to be m, because m is our slope, right, equals 2. That's our slope. Now, after you have your slope, what we need to do is we need to identify the y-intercept from the graph. And so what we need to do now is to get that y-intercept, we need to graph these points. So -1, -5, so -1, -5 is going to be right here, right? We also have 3, 3, so over 3, up 3. And that's all we need. So from here, we can do our slope, which is 2. So I'm going to go up 2, over 1. And right there, I'm already getting my y-intercept, which is going to be at -3. So my y-intercept, we just found it, our b equals -3. And then after you have your slope and your y-intercept, we're done. We just do y equals, and that's always going to be there. 2 is going to replace m, x minus 3. Notice how all I did was replace my m and my b with my corresponding numbers, and I kept y and x in the exact same location. Now, we can do this exact same thing, but with 2 points. But the first thing we have to do is use rise over run to determine the slope. And if we plugged these points into the formula y2 minus y1 over x2 minus x1, we're going to get m equals -1 over 3. And after you have your slope, what we can do is identify the y-intercept from the graph. And so after we plot these points, let's plot them. So we have 6, 3, so 6, up 3, 1, 2, 3. And then we also have a point at -3, 1, 2, 3, up 6 here. And so now we can do our rise over run, which is down 1 over 3. So down 1 over 3, 1, 2, 3. We're already hitting our y-intercept. And it looks like our y-intercept is at b is 5. Once you have your y-intercept and your slope, you can just plug them into the equation. Y is always going to be there, equals, our slope is -1 over 3, x plus 5. And there you go. I'm going to run out of time, so watch the next video to finish my examples here.